Welcome to Context Window, your weekly look at the bleeding edge of AI coding tools. Let's see what's new.
All right, let's dive into the latest from the AI tooling landscape, starting with GitHub Copilot, the incumbent giant, always making headlines. What's the word this month?
Well, it wasn't a good month for trust. GitHub Copilot just faced massive community backlash. On March 30th, it was caught injecting promotional ads for a productivity tool called Raycast into over 11,000 automated pull requests.
Whoa, hang on. Ads in pull request? That's beyond a red line. That's treating production code like a freemium social feed.
It absolutely is. And as if that wasn't enough, they also announced a new data policy. Effective April 24th, interaction data from free, Pro, and Pro Plus users will be used to train future models unless you explicitly opt out.
An opt-out policy for training data? Coming hot on the heels of injecting ads into code? It really feels like Microsoft is testing the limits of its monopoly. If Copilot is writing your PRs, you're no longer the author. You're just the audience.
Precisely. It's a bold move, to put it mildly.
Switching gears to Cursor, they've been moving fast, but this sounds like a new level of velocity.
They're absolutely blistering. Cursor just launched its Composer 2 engine. This thing is leveraging real-time reinforcement learning to deploy a new model checkpoint every 5 hours.
Every 5 hours? That's an insane engineering flex. I can barely keep my operating system updated every 5 days.
Right? It's a testament to their focus on speed over stability. And they're aggressively moving upmarket, too. On March 25th, they released self-hosted cloud agents directly targeting highly regulated enterprise customers who are paranoid about IP leakage.
So Cursor isn't just an IDE anymore. It's becoming a localized engineering manager capable of orchestrating multiple AI agents and is gunning for enterprise seats. They're optimizing for velocity above all else.
That's the read. They're trying to differentiate themselves with sheer pace and multi-agent orchestration.
Let's talk about Anthropic's Claude Code. We've seen it gain serious traction in the CLI space. What's new there?
Claude Code, their CLI native tool, just crossed 84,000 GitHub stars and rolled out a major memory update. It now uses persistent project settings, like a .claude/settings.json file and a claude.md to retain project context and debugging patterns across sessions. This was a huge complaint about CLI agents, context amnesia.
That's a significant improvement for CLI tools. But I'm seeing a breaking update here in the notes. What happened?
This is a devastating operational blunder. On March 31st, the full source code of the Claude Code CLI, all 1,900 files, over 512,000 lines of TypeScript, was leaked. It happened via a .map file exposed in their NPM registry.
Wait, Anthropic, a company that prides itself on AI safety and security, accidentally open-sourced their entire CLI by forgetting to strip source maps? That's a junior-level web dev mistake for one of the smartest AI labs out there.
You couldn't make it up. It's a stark reminder that even with cutting-edge AI, the basics can still bite you.
Okay, so you're telling me that after all the hype, after all the promises of exponential productivity, these AI coding tools are actually making developers slower?
Not just slower, but in some critical ways, actively creating more work. The data is starting to show that the honeymoon phase is definitely over. We're talking about a 19% increase in task completion time, not a reduction.
19% longer? That flies directly in the face of every vendor benchmark we've seen. This isn't just a slight deviation. This is a complete reversal of the promised ROI.
Exactly, and that's just the start. We're seeing an 8-fold increase in duplicated code and a complete collapse of healthy refactoring practices. The narrative pushed by the big players, full of sterile benchmark scores, is violently colliding with the gritty, messy reality of day-to-day engineering.
We just ran through a rapid-fire update of the latest moves in AI coding tools. But the real story, as we teased up front, is the growing chasm between vendor claims and developer reality.
That's right. The foundation for our deeper dive today is a fascinating viral developer diary from March 2026. A back-end engineer spent 30 days rotating between Claude Code, Cursor, and Copilot, all on a wonderfully messy, real-world stack: Python Fast API, TypeScript, and a legacy Django monolith. And what they found exposes a massive disconnect.
This engineer's experience directly challenges the rosy picture painted by AI vendors. They often point to benchmarks like SW Bench, right?
Absolutely. SW Bench measures an AI's ability to resolve GitHub issues, and you see numbers like Anthropic heavily promoting Claude Sonnet 4.5's 77.2% solve rate. It sounds impressive on paper, but as researchers from MET, the Model Evaluation and Threat Research Group, point out, these tasks are highly sanitized.
Sanitized meaning they don't reflect the chaos of actual development?
Precisely. Real-world work involves tacit knowledge, undocumented legacy systems, and architectural dependencies that benchmarks completely ignore. A 77% solve rate in a sterile lab simply does not translate to a 77% reduction in a developer's workload. It's an illusion.
And you mentioned earlier that it's actually making developers slower. Let's dig into that productivity paradox with some hard data.
We have two critical pieces of empirical research here. First, that Metra study I referenced earlier. They tracked the time it took experienced open-source developers to complete tasks using AI tools. And the early findings are startling. The use of AI tools actually caused tasks to take 19% longer.
19% longer? That's not a marginal difference. That's a significant drag. What's driving that?
It's all about the friction, the massive overhead involved in prompting the AI correctly, setting the context, and then, crucially, meticulously reviewing the AI-generated code for subtle logic errors. While the AI might speed up the initial typing, it drastically slows down the review and verification phase, which is where real bugs are caught or introduced.
So it's a bit like giving someone a super fast car, but the road is full of potholes and you have to constantly stop to check the map and adjust the tires.
A perfect analogy. And if that wasn't concerning enough, the second piece of research points to a looming technical debt crisis. GitClear analyzed over 211 million changed lines of code authored between 2020 and 2024.
211 million lines. That's a massive data set. What did they find?
Their findings are staggering. They observed an 8-fold increase in the frequency of code blocks with 5 or more lines that duplicate adjacent code. Think about that. 8 times more duplicated code. And the percentage of moved code, which indicates healthy refactoring and code reuse, plummeted from 25% in 2021 to less than 10% in 2024.
And I'm guessing copy-pasted code went up.
Significantly, it rose from 8.3% to 12.3%. It's a clear signal that AI tools are actively destroying the don't repeat yourself, DRY, principle, a cornerstone of good software engineering.
So developers are using AI to apply quick patches, duplicate existing functionality, rather than taking the time to properly refactor and clean up legacy modules. This sounds like a fast track to a maintenance nightmare.
It absolutely is.
API evangelist Ken Lane put it starkly. I don't think I have ever seen so much technical debt being created in such a short period of time during my 35-year career. This isn't just about speed. It's about the long-term health and maintainability of our software systems. The benchmarks might look good, but the real-world impact is a growing mountain of future problems.
That's a powerful and chilling observation. So, if these tools are creating more friction and more debt, how are developers actually using them? The 30-day diary also sheds light on the fundamental differences in how tools like Claude Code and Cursor are designed, almost a philosophical divide.
It really does. The diary author found Claude Code to be unparalleled for complex back-end debugging, and that makes sense when you understand its philosophy. Claude Code isn't a traditional GUI application. It's Anthropic's official CLI tool, living entirely in the terminal.
So it adheres to that classic Unix philosophy, small, sharp tools designed to do one thing well.
Exactly. As Boris, the lead engineer for Claude Code, explained, it's designed as a Unix utility rather than a bloated product.
It provides raw, direct access to the model. This makes it a cockpit for power workloads.
A cockpit? What does that mean in practice?
Think about it. Because it's terminal native, a developer can use it to automate massive workloads. For instance, spinning up 1,000 instances of Claude to fix 1,000 separate linting violations, and then generating individual pull requests for each. That's a power user's dream for certain kinds of tasks.
That sounds incredibly efficient for batch operations, but I can already imagine the downsides for other types of work.
You're right. The diary author noted severe downsides, particularly for front-end visual iteration. Because it lacks a visual interface, you can't easily see inline diffs or highlight specific code blocks with your mouse. It's a very different workflow. Plus, terminal sessions traditionally suffer from context amnesia.
Which is why that memory update we discussed earlier was so crucial with the .claude/settings.json and claude.md files.
Exactly. Anthropic is trying to solve that context problem, but it still introduces workflow friction. Now, compare that to Cursor. The diary author likened it to a familiar studio. Cursor is a fork of VS Code, meaning it retains all the visual comforts of a traditional IDE.
So it's leveraging a developer's existing muscle memory and environment.
Precisely. And its Composer feature allows developers to orchestrate multiple AI agents simultaneously within that familiar visual environment. The diary author found Cursor to be the absolute best tool for greenfield feature development.
Greenfield, as in starting fresh, building new things from scratch.
Yes, developers can visually steer the AI, highlight code directly, and see inline diffs immediately. It's a very interactive, iterative process. If Claude Code is a scalpel for precise backend logic, Cursor is a paintbrush for rapid prototyping and visual iteration. They represent two fundamentally different philosophies for integrating AI into the coding workflow.
It highlights that there's no one-size-fits-all solution, and the right tool depends heavily on the task at hand and the developer's preferred workflow. This brings us to GitHub Copilot again. How does it fit into this philosophical split, and what are its particular strengths and, more importantly, its limitations?
When the diary author returned to GitHub Copilot in week 4, they described the experience as frictionless. Copilot relies on the familiar tab to accept autocomplete model. It operates quietly in the background, predicting the next few lines of code without requiring the developer to stop and write a detailed natural language prompt.
That's why I felt so revolutionary when it first came out, right? It just feels easier. The path of least resistance.
Absolutely. It's incredibly good at making you faster at typing what you already know you want to type. It smooths out the rough edges of common coding patterns and syntax. But the diary highlighted a hard ceiling to this frictionless approach.
A hard ceiling? Where did it hit its limit?
When faced with a truly complex production incident, specifically a memory leak resulting in out-of-memory kills, Copilot was entirely useless. It couldn't help.
Because it lacks that deep project-level awareness? It's not designed to navigate across 15 different files in a legacy Django monolith to hypothesize why a database connection pool is leaking memory, for example.
Exactly. Its architectural blind spots become glaringly obvious in those scenarios. It can't autonomously understand the intricate, undocumented dependencies of a complex codebase. It's an edit loop optimizer, as a highly upvoted Reddit analysis from March 2026 put it. It makes you faster at the immediate task, but it struggles with the bigger picture.
So if you just let Copilot do its thing on a complex code base, it's likely to drift from the intended architecture, even generate code that looks syntactically perfect but is architecturally disastrous.
That's the consensus among senior engineers. The only way to make Copilot reliable on complex projects is to implement a strict spec-first workflow. The human developer has to first write a rigorous, detailed specification, perhaps in comments or a markdown file, heavily constraining the AI.
So Copilot doesn't reduce the need for detailed planning, it actually increases it. Without those human-imposed guardrails, its frictionless autocomplete confidently generates hallucinations.
That's the takeaway. The frictionless experience comes with a hidden cost of architectural drift and potentially significant rework if not rigorously managed. It exposes the critical truth that for complex problem-solving, context and architectural understanding trump raw speed.
This all leads us to a really interesting and frankly concerning trend:
vibe coding. This idea of delegating too much autonomy to AI agents.
Vibe coding was coined by Andrej Karpathy, former OpenAI founder, back in February 2025. It's the practice of generating software entirely through natural language prompts to an LLM without manually writing or even fully reviewing the code. Karpathy famously described it as developers being able to fully give in to the vibes, embrace exponentials, and forget that the code even exists.
Forget that the code even exists. That sounds utopian or perhaps dystopian, depending on who you ask. What's the real-world ROI of that approach?
The real-world implications of that approach are proving to be quite messy, particularly when it comes to security.
So, vibe coding isn't a silver bullet, and I suspect there are even more alarming consequences beyond just productivity. Security, perhaps?
Absolutely. This is the most alarming consequence. When developers forget the code exists and blindly accept AI outputs, they introduce massive vulnerabilities. As critics on Hacker News have pointed out, AI models frequently generate code with broken corner cases, security vulnerabilities, and missing error handling. Relying on vibes rather than rigorous code review is a recipe for catastrophic breaches. It's putting our systems at incredible risk.
So for tech leaders, for investors, for senior engineers listening to this, the message is clear. Chasing the vibe and blindly trusting AI has severe real-world costs.
Precisely. Enterprise success in 2026 depends almost entirely on organizational discipline, not just on which tool wins the latest benchmark. As ThoughtWorks noted in their recent technology radar, AI-driven confidence often comes at the expense of critical thinking, a pattern we've observed as complacency sets in with prolonged use of coding assistants.
So instead of being a substitute for critical thinking, AI actually demands more of it.
Exactly. Teams must implement strict guardrails, mandatory test-driven development, aggressive static analysis, and rigorous human code review. These aren't optional anymore. They're essential to manage the tidal wave of technical debt and security vulnerabilities generated by autonomous agents. It's a powerful reminder that the human element, far from being replaced, becomes even more critical in an AI-assisted world.
That's a sobering thought, but an essential one. We've covered a lot today, from the breaking news in the AI tooling space to the deep philosophical divides in how these tools are designed and used.
Indeed, the core takeaways are really crystallizing. First, those standardized benchmarks, like SW Bench, are largely an illusion. They measure isolated puzzles in a sterile environment and completely fail to account for the UI friction, context switching, and review time overhead that actually dictate a developer's day. That Metra study showing a 19% slowdown for experienced developers is a critical piece of data.
And we saw that philosophical divide play out. The terminal-native cockpit approach of Claude Code, built for power users tackling complex back-end logic, versus Cursor's Studio approach, a highly visual, interactive environment perfect for rapid front-end prototyping and greenfield development. Different tools for different jobs, but each with its own friction points.
Yes, and then there's Copilot, which remains the king of frictionless autocomplete. But as the 30-day logs reveal, it's fundamentally an edit loop optimizer. It has a hard ceiling. It lacks the architectural awareness to navigate legacy code or debug cross-file production incidents. It only works reliably with a strict spec-first workflow and heavy human guardrails.
Which brings us to the biggest warning sign, the danger of vibe coding. Andrej Karpathy's dream of forgetting the code exists is, in practice, turning into a security nightmare. With GitClear tracking an 8-fold increase in duplicated code, it's clear these tools demand more human vigilance, not less.
Absolutely. The most successful teams aren't going to be the ones who blindly embrace AI autonomy, but those who strategically integrate it with rigorous human oversight and strong engineering discipline.
It really makes you wonder, how will development teams adapt their entire processes to manage this AI-generated technical debt? And can we ever trust AI to author critical infrastructure without exhaustive human oversight? Or are we just shifting the risk?
That's all for this episode of Context Window. Join us next time for more on the AI tools shaping how we build software. If you're building with AI, subscribe. We cover what matters.
Ship smarter, not harder.